so we've got three forces. And a free body diagram. So we've got X. I'm just going to re-sketch this, just something to work with. So here's our Y direction, which also has a force, F2, which is equal to 200 newtons. We've got our F total, which is at a theta prime equals 60. We've got an F1, which acts at some angle from our F total. I believe our F total is given as 800 newtons. And we've got an F3. Drawing straight lines is not my forte this morning. F3, which is 180 newtons. And it's given, we're shown a similar triangle on the vector, which is a 12, 5, 13 triangle. Okay, so first of all, I'm going to drop that there and say that's phi. And so let's figure out all our vectors here and then figure out what our total would be. So our F1 is, our F1 vector is going to be our F1 magnitude times our cosine of phi I hat. So that's going to be my my x unit vector plus F2 sine phi j hat. My F2 force is straight up, so it's just my F2 j hat, so that comes to 200 newtons times j hat. And then my F3 is, again, I'm gonna just call that angle gamma. And so we can see that it's minus 180 newtons times cosine of gamma in the I hat direction plus 180 newtons sine gamma in the j hat direction. So we can solve for our angle here, or we can solve for the values directly. So we're shown for F3 a 12, 13, 5 triangle. So that means that cos gamma, and this is gamma in here, cos gamma is the adjacent over the hypotenuse, so 12 over 13. And sine gamma is 5 over 13. So again, we could solve for gamma, but we actually already have our values. So F3 is minus 180 times 12 over 13. I hat plus 180 times 5 over 13. So we don't need to bother actually solving for the angle there. Now we can get our total vector by looking at the triangle we're given there. So we're given this one, where that's 60 degrees. There's our F total, which is 800 newtons. And so we can see that this side is f total cosine of 60, and this is f total sine of 60. So our f total vector is ft sine 60 in the I hat plus f total cos 60 in the j hat, which is 800 newtons times the sine of 60 is root 3 over 2, and the cosine of 60 is a half. Okay, so now we have each of our vector quantities. I didn't do. F1. We'll just have to solve for its components. And the best way here is to look at the directions separately. So in our x hat, well, first I guess I should just start by saying that remember our F total is just the sum of our forces. So if we look in just the x hat in the x direction or the I hat direction, so just take the I hat components. We have 800 newtons times root 3 over 2 is equal to our F1, which is just F1 cos phi, plus our F2, which is 0 in the x direction, plus our F3, which is minus 180 times 12 over 13. And so we can rearrange this and say that F1 cos phi is equal to 800 times root 3 over 2 plus 180 times 12 over 13. I could work this out, but rather than working completely in decimals, I figured I would just leave it. Now in the y hat direction, or in the y direction or the j hat direction, we have 800 newtons times 5 over 13, times a half is equal to F1 sine phi plus 200 newtons. And so that's the F2 component, and then the F3 component is 180 times 5 over 13. So then we can rearrange this for our F1. Say that F1 sine phi is 200 is 800 newtons divided by 2, which is just 400 newtons. So I'm working that one out because then I don't have to worry about the decimals. Minus 200 newtons minus 180 newtons, 5 over 13, which is, and I can do that subtraction pretty readily. And there we go. Okay. So now I have two equations here and two unknowns. So there's my first equation. And here's my second equation. And I'm just going to divide the second equation by the first equation, which will give me F1 sine phi over F1 cos phi equals 200 newtons minus 180 newtons times 5 over 13 over 800 newtons root 3 over 2. Okay. And now, now I actually need to do some of this. But first, let's cancel out these f1s. Sine phi over cos phi is tan phi. And now, if I work this out on my calculator, the numerator here gives me 130.769 newtons, and the denominator becomes 858.974, which gives me a phi of 8.656 degrees. And then my force, I can use either of the equations. So I can say that F1 times the cosine of 8.656, which would be the first equation there, is equal to 400 newtons. It's equal to, I'll just again keep it all worked out here, so it would be this 858.974 newtons. So then my F1 comes out to be 868.871. Okay, and then so I've got my force, I've got my phi. So there's my my value for F1. If we look at the figure though, it wanted, so there's my 60 degree. It wanted this theta, the F total, F3. And so we just calculated this angle. And so then recognizing that that's a 90 degree angle, so 60 degrees plus theta plus phi is equal to 90. So then theta is 90 minus 60 minus phi, which is 30 minus this 8.656, which comes out to be 21.344 degrees. And so there's the F1 and the angle they were looking for. So about 869. And the angle is about 21.3. So that looks good.